Welcome to Unit 5, Polynomials. So we're going to start right off the hop diving into polynomials that are of a higher degree than 2. So up to this point, you've pretty much exclusively worked with quadratic equations. So x squared being your highest kind of power. This unit focuses on what happens when we have higher powers, so like cubics, quartics, etc. So before we get into that, we need to recall some long division. Now, you might have learned it a slightly different way than I did, but the general idea and notation for long division hasn't changed. We write it like this, and you might have written it like as a curve. I try to write it as a like square sign, only because then I don't ever start to think that it's that, which is a square root. Okay, so I always try and do a straight line instead. Okay, and then we write the number that's getting divided underneath. Now, how I learned, and again, you might have learned differently, but the process should still be the same, is we're trying to see how many times does 13 go into this. So we start with looking at 13 going into 27, and that happens, well, into 2, and that doesn't happen at all, so that's not an option. Into 27, it happens twice, which means that 2 times 13 is 26, which leaves me with 1, and I carry down the next number. And I look and say, okay, 13 goes into 14 once, and I put the 1 on top of the last number I'm looking at. So 1 times 13 is 13, leaves me with 1, bring down the 8, and I look and I'm like 13 goes into 18 only once again, and so that 1 times 13 is 3, and that leaves me with 5, and that's my what we call my remainder. This means that 13 does not divide evenly into 27 or 2,748. Okay, because I have that remainder. In order for it to divide evenly, we would expect this number at the end, when I reach that final digit, to be a 0. So if we try this next one, and again, you can do this by practice, or you can just kind of follow along here, because this is not actually what the unit is about. 23 does not go into 12 even, so I'm going to have to start all the way back at 123, which goes in 5 times. I know that because if I start working with like 25s, I can estimate that. If you don't believe me, you could double check, I guess, with your calculator by multiplication. So 5 would give us 5 times 3 is 15, 5 times 2 is 10, add another 1 though, 115, and so when we subtract this, I end up with 8 left over, and we bring down the 4. So again, we see that 5 lined up with the 3, because I stopped there, and that was the number I was trying to see how many times 23 went into it. Okay. 84, I would expect this to go in 3 times. 9. Oh, and you know what? I'm looking at this, and I think it's actually 4 times. So there's a little bit of guess and check involved. Approximating 4 times 4, or 4 times 3 is 12, 8. No, I was right. Okay, so I would subtract this from here, 8, 7, 1, 15, yeah. Silly me. Okay, and then I'd bring that last 5 down. And it goes into 155. I would guess that it would be 6 times. So 6 times 23 would be 6 times 3 is 18. 6 times 2 is 12, so 13. That would leave me with 17 is my remainder. So if I wanted to write like a final solution to this, because again, I have a remainder, I would say that my answer is 536 and 17/23. And that denominator piece is the same denominator that I would have had if I had written this in fraction form. So the number doing the dividing. Okay, so that's how we would write it. And you could convert that to a decimal if you had access to a calculator, but we're trying to not. So dividing a polynomial is much the same process. Okay, so we look at, we're going to look, because we're dividing by a binomial, so let's just label some terms here. This is a binomial, because there's two terms. Okay, whereas this is a polynomial. We're going to use that for anything greater than, well, anything with 3 or more terms. Okay, and we can actually divide this like long division. So we would consider the first two terms and say, okay, well, how can I make this happen from here? And specifically, I always look at my first term. I don't really care about the second term. The second term just kind of happens. So I look and I say, okay, how do I turn x into 2x cubed? Well, I would need to multiply by 2 to make that coefficient appear. And I would need 2 more x's, so x squared. Now that multiplies by both terms. Okay, so again, our first step is just how to turn first term in binomial into first term of polynomial. Once I do this, I multiply the first term and I know I'm going to get 2x cubed. And then multiplying by the second one, I'm going to subtract 2x squared. But I'm going to subtract all of this from the previous one. And what that does is it allows me to knock out this first term completely. And remembering that a negative times a negative is like a positive. This is going to give me 5x squared. And I'm going to bring down the next term, just like I brought down the next number up here. I brought down that 4. Now I'm looking at this, and again, I look at the first term that I have down here to work with, and I'm going to say, what do I multiply my first term of my binomial by to get that? Well, in this case, I want to make 5x squared, so I need that 5 because I've got nothing out in front of x right now. And I need one more x, so that's exactly what I'm going to put there. And then I'm going to distribute that to both terms. So I've got 5x times x is 5x squared, and 5x times negative 1 is negative 5x. But again, I'm subtracting this. So 5x squared minus 5x squared is gone. Subtracting a negative is like adding. So 2 plus 5 is 7x. And then I still have to bring down that 5. This is where being like really organized and conscious of like stacking columns is really, really important. So finally, I'm at this last piece and I look at 7x. How do I make that from x? Well, I just need a 7. and I distribute that to both terms, and these arrows are starting to get pretty messy, so you do not need to write those arrows by any means. 7 times x is 7x. 7 times -1 is -7. I'm subtracting all of it, though, to make it go away, which means it's really like I'm adding 7, so this is like positive 12. Because I didn't get 0, this is just like long division. This is my remainder. So this is really like the goal of each step, how to turn the first term of the binomial into the first term of the polynomial. Your remainder is what you're left with at the end, along with this is your solution. Or like the whole, or how many times. Okay, so our whole solution then would be this whole piece up at the top, 2x squared plus 5x plus 7, plus we need to include that remainder, but just like up here, how we had to include the denominator still, include the number we were dividing by, we would still include that piece here. X minus 1. So that would be my final solution. Okay, so again, always trying to turn your first term into the first term of the binomial underneath your division sign, and then your remainder is always written as a fraction over what you were dividing by. Okay. In general, division statement for px equals x minus a qx plus r, where px is the original polynomial, x minus a is the binomial divisor, qx is the quotient polynomial, which has a degree 1 less than px, and r is the remainder, which is a constant. Okay. So what that means is that when we look at this, kind of defining all of those things, px would have been my original thing underneath the division symbol. So that would have been 2x cubed plus 3x squared minus 2x plus 5. X minus a in this case would have been my x minus 1, my binomial that was doing the dividing. Qx is going to be my answer at the top, not including my remainder. And then my remainder would get listed here. And it's just 12. Okay, so the solution for division, I'd need to include that denominator. If I'm filling it in this division statement, though, I can just write the remainder as it is. You very infrequently see this kind of notation, but just in case you're wondering or you ever run across this. Okay, and so key thing there is that your remainder should always be a constant. Okay, and notice that qx is a degree 1 less than px, so we see 3 is px, 2 is my qx, and that makes sense because I've taken out that x squared. So if I distributed this back in, I would have to multiply this by x, and that would get me my cubic back. I was trying to simplify. Funny page formatting there. Okay, so if you want to give this a pause and give it a shot, or if you want to follow along to the next example, I'll walk you through this one. Example 3 you can try on your own. Yes. So example 2, one thing I want to note, and this is something you want to check for right away when you go to divide any sort of polynomial by a binomial, is you want to look at your powers and make sure all of them are accounted for, and they should decrease by 1 for every term. So here I look at 4, 2, 1, 0. The fact that I am missing 3, or an x cubed term, means that when I go to write my division out, I'm going to have to put a 0 in its place and make sure that all degrees are accounted for. So what is that going to look like? Well, it's going to look like this. I've got x minus 3 is on the outside still. That hasn't changed, but instead I'm going to write negative 4x to the 4 plus 0 plus 2x squared minus x minus 3. And I'm doing that so that I can account for the fact that there should be a cubic, and there obviously isn't, which means that something funny is going on. Okay, so again, we get this missing term needs to be accounted for by a 0. You could have said minus 0 too, doesn't matter. Okay, so now we dive in and we're like, okay, well, x needs to turn into negative 4x to the power of 4. So we need the negative 4 because that's non-existent over here. And we need 3 more x's, so x cubed. And that gets me negative 4x cubed. And then multiplying it also by negative 3. Would get me positive 12x cubed. Remember, all of this is getting subtracted because we want to eliminate this first term, which means I'm really subtracting 12x cubed, leaving me with negative 12x cubed. So that's the next term I need to make using my x from my binomial. So I look and I'm like, okay, well, that's great. I need a negative 12x then. X squared actually, because I need 2 more x's. And so when I multiply that out, oh, and don't forget to carry down this, plus 2x squared. So I've got negative 12x cubed, great. I'm subtracting that, but I'm also dealing with negative 3 times negative 12, which is positive 36x squared. Again, I did all this to get rid of my first term. I've got 2x squared minus 36x squared is negative 34x squared. I'll write that in black. And I'm going to carry down this other negative x. I look here and I'm like, okay, how do I make this from x? Well, I need a negative, switch up colors. Need a negative 34 and then 1 more x. That leaves me with negative 34x squared. But then adding 90, 102 x's. But again, I'm subtracting all of this to make that first term go away. So I'm really subtracting 102 from 1. So it's negative 103x. And I bring down this negative 3. I'm at the end of my polynomial, so this is my last step, so thank goodness for that. I turn x into negative 103x by multiplying by negative 103. Which leaves me plus 309. These go away. Negative 3 minus 309 gets me negative 312. And this is my remainder. So again, how I would write my solution is I would write what's up here. What's my even solution if it went in evenly? But I also need to remember my remainder, which is negative, so I'm not going to add it. I'm going to subtract 312 divided by x minus 3. So it doesn't get pretty all the time. It doesn't end with no remainder, but sometimes it does. Definitely not in this case, though. But it was essential to include that 0 and account for it and use it throughout this process. Example 3 is much the same. First thing you want to do again is check your powers of your polynomial. So we've got 4, 3, 1, 0 as my exponents with x, which means I need something to stand in for my missing x squared. So you can pause the video now, give this a shot. I'm not going to walk through every step, but I will have all my work shown at the end, and I'll point out a couple key things. Okay, so here's kind of my work for this. The first thing I did was I rewrote my question to include that 0 in place of my x squared term so I didn't forget about it. Once I've done that, same process applies. I look at my first term in my polynomial, say how do I create that using my binomial, and I go from there, and remembering to subtract each time so that that quote first term keeps disappearing. And I'm able to like progress down the line and look at each term. Okay, again, my solution is written in a way that I include everything from above the division symbol, plus my remainder divided by the number, the binomial that's doing the dividing. But that's been a lot of writing and a lot of like rehashing, and it takes up a lot of space. And math, if you haven't noticed, we do try to be efficient as much as possible. Sometimes it sure doesn't feel like that. Our math proofs in proving trig identities sometimes take up a lot of space, and it feels very much like we're not efficient. Okay, but when it comes to anything related to our like operations, adding, subtracting, multiplying, and dividing, we do really try to be efficient. And that's where synthetic division comes into play. So up until this point, we've been doing what's called long division. Synthetic division can be used to accomplish this exact same goal as long as a is an integer. So as long as this value in our binomial that's doing the dividing is an integer. Okay, we basically take out the variables so we can ignore them, and we only look at the coefficients. This works out nicely because it kind of helps us, again, be quicker and just look at the values of things. And the actual exponent numbers are implied. So instead of writing x minus 2 in this question, we identify that the a value is positive 2 based on our general formula because it's already subtracting. So a becomes 2. And from there, we're going to look at how it goes into the coefficients. It addresses these. So we set it up a little differently. Our line looks like this. We put our a value here, so that's 2. I'm going to put my coefficients up on top. So I've got 5, x squared is implied, 7, x is implied, and negative 4. And whatever number's left under the 4 is my remainder. Okay, so what we do here is first we bring down the 5. The second thing we do is we multiply 2 times 5, which is 10, and we record it here underneath our second coefficient. We then add. So 7 plus 10. Okay, so step 1 was just rewriting the 5. Step 2 was multiplying 5 by the value of a, which was 2, and rewriting it under 10, and adding it, which is 17. We're then going to multiply 2 by 17, which gives me 34, and we're going to record that under -4. We're then going to add these, and that gets me 30. That was my third step. The remainder, like I said, is the number that's left under what was our constant term. Conversely, this is the kind of like whole solution if x minus 2 went in evenly. Also known as your QX piece from way back when we kind of wrote that division statement. Okay, so if I wanted to actually write my final answer though, I'd have to put my coefficients back, and remembering that my x coefficients always decrease by 1, so going back here, my highest degree is x cubed here because I started with x to the 4 in my original question. Again, x cubed when I started with x to the 4 in my original question, and x squared when I started with x cubed in my original question. So with all of that in mind, I know it's a lot, my solution would be 5, and then it would be 5x and not 5x squared, because 5x squared was my original polynomial that I was dividing, so I should decrease my power by 1. And then my second term would not have an x at all because we always decrease by a power of 1 or an exponent of 1, so it should be just plus 17. And then my remainder would be 30 over x minus 2, and that would stay the same. I'd reintroduce that binomial again. Okay, and so again, we're seeing that this polynomial, since the dividend is a polynomial of degree of 2, the quotient is a polynomial of degree of 1, and that's what we're seeing right here. Versus here, the degree decreases by 1. Okay, so I will walk through the next example, but if you want to give it a shot on your own, you're more than welcome to. Just pause the video right now. Great, so again, a couple of things to note right at the beginning of using synthetic division is that in this particular case, because in general we say x minus a is our divisor, a in this case would have to be -2, so changing that sign. Again, I'm going to look at my exponents and make sure that they are decreasing by 1 each time, and I notice that I am missing my x squared term. So again, when this is happening, I'm going to put a 0 placeholder in there, strictly so that I can make sure that all those terms are accounted for, because that has to happen for a reason, and we need to have some way of explaining it when we start dividing it out. So how I'm going to set this up for synthetic division looks like this. So I'm going to go -2 on the outside of my big L. Just for trying. I'm not very good at drawing straight lines, as you guys are probably aware by now. And then I look at my coefficient. So for my x to the 4, coefficient is 3. X to the 3, coefficient is -1, noting that the number is not there, but we need to have a number filled in. My missing x squared means that it's 0. Okay. Then we've got +3 for x, and then -20. And that's where my remainder is going to be. So I always like to draw that line in, just to kind of remind myself. So first step, carry down the 3. Second step is -2 times 3 is -6. Write it up here. Add them together gives me -1 plus -6 is -7. Then I'm going to go ahead and multiply -2 by -7 is 14. 0 plus 14 is 14. Then I'll multiply again. -2 by my more recent number is going to be -28. Add them together is -25. Times 2 gives me 50, which means me with a +30 remainder. You'll notice that this example is, if I'm not mistaken, the same as our example up here. And you'll notice my remainder is 30, and my coefficients here are 3, -7, +14, and -25. The same thing happens here, 3, -7, +14, -25, remainder 30. So both methods work exactly the same. And again, my solution would be this kind of bottom part. And so the only thing I'd have to remember is that I have to decrease that x exponent by 1. So when I write 3, I'm talking about x not to the 4, but to the 3. Oops, so I say that and I write 4. Okay, and then going from there. -7x squared plus 14x, and then -25 plus my remainder divided by my binomial. And again, having all sorts of problems there. When I write this final solution, I need to remember that my denominator is not just this number out in front, not my a value, but the actual binomial. Okay, so it's the original divisor. Okay. So we've got a couple more examples here, and then we will hit the bottom of page 6, and that is the end of our lesson. So you've got 2 examples here. If you want to pause now and give them a shot on your own, I don't think that that's a bad idea. You can check your answer by long division to practice that as well. I'm going to do synthetic division for both of them. I'm not going to include a full me explaining things orally, but I will include some details as I finish each one. So that's what you're going to see at the end of this lesson, is just some breakdowns of the solutions of these. So pause now and give example 3 and 4 a shot on your own. So again, when we look at this one, we carry down that first number without doing anything because we had nothing to kind of multiply by. So we carry that down and we just drop the exponent from 4 to 3. We then multiply our a value by this bottom one and add it to our next coefficient. And we carry that kind of process through. And we do, unfortunately, have a remainder, so we need to make sure that that's included. You could also say plus -39. I just have a tendency to move my integer signs out into operation signs, just personal preference. But that would also be totally acceptable. So you would totally be fine if you wrote plus negative 39 over x plus 2. That would be okay. All right, so again, pause, give example 4 a shot. So before you give example 4 a shot, you probably got to it and were like, what am I supposed to do? I have a coefficient with my x value. So you've got a couple different options. Option 1 is you can factor out, luckily it is factorable, you can take out that coefficient and break it down like this. I also notice right away that I can take out a 2 from my actual polynomial here and factor that out. And that leaves me with 3x cubed plus 2x squared plus 4. And if we've got 2 divided by 2, well, they're nice and simple. They just go away. And now we can work with these polynomials here. If that doesn't make sense, and I can do synthetic division from there. If that doesn't make sense, you can do long division this way. So I'm going to work through both options, and I'll have both solutions here. I'm going to do the synthetic division for my now simplified polynomial on the left. I'm not going to explain that one, but then I will work through the long division option. So feel free to pause and try synthetic division again now that we've looked at that. So doing synthetic division, again, noting that I was missing that x to the power of 1 term, so I filled it in with 0. I'm able to do this, and because I'm using synthetic division, when I have my remainder, I still need to write it as binomial denominator, and I'm using my simplified one. Okay, so just kind of as a heads up. If I'm doing this via long division, it's going to look a little different because I've got 2x plus 4 out here. And then I've got my whole 6x cubed plus 4x squared. I'm still going to put plus 0 to hold the place of that x, and plus 8. So you could even say plus 0x if that helps you keep that straight. But again, the key thing is that that's in there strictly holding place value. So look at this first one number, and my process still remains the same. I need to create this using 2x. So 2 times 3 would give me 6, and x times x squared would give me x cubed. And once I do that, I'm going to distribute it through to both terms to get my new binomial. Okay, but again, I'm subtracting this, so those go away. That was the whole point. That leaves me with negative 8x squared. And I'm going to carry this down, plus 0x. So how do I make negative 8x squared from 2x? Well, times negative 4x would get me the parts that I am kind of missing to create that product. I'm going to distribute it through, and that gets me negative 16x. But again, remember you're subtracting this, so all your signs change. So that's cancel, and that is like adding 16x. I'm going to carry down that 8. And to create 16x from 2x, I would need to multiply by 8. Distribute it to both terms of my binomial. And that leaves me with 16x, and then 8 plus times 4 is 32. But again, remember that you are subtracting. These go away. You can write 0 under each of these. That's totally fine. I just don't. And that's okay too. And then 8 minus 32 would be negative 24. You're like, okay, well, that's great. And this part up here matches what we have over here. So that's awesome. That means that both ways work. But this part does not match my remainder from my long division. And the reason that is because we didn't factor out that 2 here. So my original solution, based on what I've done so far in long division, would be 3x squared minus 4x plus 8 minus 24 over 2x plus 4. But again, I can still simplify that binomial, and I could rewrite it as 3x squared minus 4x plus 8 minus, if I factor out that 2, 24 divided by 2 is 12 over x plus 2, in which case we do see that it still does match up. So again, there's lots of practice questions posted. They're here, and they are also in our Office 365 folder if you want to print them out. So you can check this out. There is, if it loads, an answer key where you're going to see that remainder notation. Okay. The second practice sheet is a little bit different in that you should be getting more answers that are evenly divisible instead of just having remainders. So just kind of a heads up. These ones are all squares as opposed to we've got some different options. We start with just squares, but then we progress into some more complex polynomials with like cubics in this particular worksheet. So that's kind of where we're going from to start. And lesson 2 will be posted shortly. It's kind of in the same vein, using the same idea. We will be doing some dividing. Synthetic division is definitely going to be a key thing for you here. So you really want to be comfortable with that whole piece in order to be able to be quicker at factoring these bigger polynomials. So give them some practice and ask lots of questions.